Okay, in this section, we're dealing with something called compound inequalities, which is really kind of the same thing as doing two inequalities at the same time. Okay, so it's just one more step beyond just regular inequalities we worked on yesterday. And if I have something like this, this is an AND compound inequality. Okay, it says two things. X is greater than negative 9 and x is less than 12. That's kind of how you read that. Do you see how the greater than sign facing the x is the bigger one? That means that x is greater than whatever number is to the right. Most of the time we're used to seeing x on the left. But in a compound inequality, if you want to interpret this, x is on the right, so you're looking at the sign as it relates to x. And when it's greater than, bigger opening here next to the x, you know that x is greater than negative 9. Okay? To graph this, I would put an open circle because it's not or equal to. And I would have 12 out here with an open circle. And it's greater than negative 9, so every number greater than negative 9 is going to go this way, and less than 12 this way. So it's going to be between these two numbers. So an AND compound inequality is always going to be filled in between the two numbers. Make sense? Okay. If I had an OR, again, I would read this as x is less than negative 9 or x is greater than 12. The OR are a little easier to figure out because they usually have the word OR when they're written. This one doesn't have the word AND, but if x is between the two numbers as it's written, you put the word AND in. X is greater than negative 9 and x is less than 12. Here, x is less than negative 9, or x is greater than 12. So in your OR statements, the arrows are typically going opposite directions. Why can't it be an AND? Yeah, there's no way I can have it both ways. I can't say x is less than negative 9 and greater than 12 because there's no number that meets that criteria. There's no number less than negative 9 and greater than 12. But there is a number that meets this criteria. 0 meets it. Any number between negative 9 and 12 meets that, right? So I can use the word AND for this one, but I can't use the word AND for the other. It has to be OR. Does it make sense? Okay? When you're solving problems that are compound, you can do them all at one time, or you can do them with two different equations if you get confused. So I could rewrite this like this. Do you see the bigger part of the inequality is facing the x? The bigger part of the inequality is facing the x. So I put the x on the left just to make it easier for solving. But to do that, I had to flip it with when I flipped the x, I had to flip the sign. Make sense? Okay. This is one way you could solve it. Just do it both. 3x plus 2 is greater than or equal to 7. Okay. And then we have Is this an and or an or? Well, the best way to answer it is to graph it. Ten-thirds is a little more than 3, right? It's wanting everything greater than -3 and everything less than, so it's an and, because it's the solution set is between those two numbers. Okay? The other way I could solve this is to just do it all at once. First step here, I'm trying to isolate x in the middle, right? So I'm going to subtract 2 from every side. Right? Then I'm going to divide by 3. And I get the same thing. X is greater than -3 and less than 10/3. Okay? To solve ORs, they're already separated for you, so you just have to solve both pieces of them. Okay? So looking at the textbook check, the compound inequality graph below would be read as what? Yes. X is less than -2 or x is greater than 1. And inequalities have shading between the two numbers. True. Or inequalities have shading between the two numbers. False. To solve this problem, the first step would be what? Subtract 1 from both sides. So this is false. And then finally, in this example, this was a paragraph at the very beginning of the section. She was trying to get an A for the class. It's good timing.